Hi friends, in the previous video we discussed about time value of money. Here we will discuss about net present value. What is it? So let us go through these lines. Net present value is the difference between the present value of cash inflows and the present value of cash outflows over a period of time. Calculating net present value involves calculating the cash flows for each period of the investment or project, discounting them to present value, and subtracting the initial investment from the sum of the project's discounted cash flows. Net present value is used to determine whether or not an investment, project, or business will be profitable down the line. Essentially, the NPV of an investment is the sum of all future cash flows over the investment's lifetime discounted to the present value. Now, we will take a simple example and try to understand how net present value is calculated. But before that, let us see how from present value we can derive future value, and from future value how we can derive present value. Assuming that we have 1000 rupees and we can get 10% of interest if this amount is deposited for 1 year. Now, after 1 year, this 1000 becomes 1100 rupees. Now, the present value is 1000, future value becomes 1100 if the interest rate happens to be 10%. So this is present value, this is future value. So present value, maybe this is this year, exactly 1 year down the line, this 1000 is becoming 1100. Okay. Now suppose we have future value. We know about the future value. Now future value is 1100 and we want to derive the present value. So next year there is a value of 1100. But what would be the value today of the same amount? Now, how we can calculate? Just the reverse. Here we were multiplying, here we will do the division. So 1100 divided by 1.1. What we are getting? We are getting 1000. Okay, let us round it off to 2 decimal. Okay, 1000. So now what happened? The future value was 1100 and we derived present value, that is 1000. And we have to understand here the concept of time value of money. It is very clear that 1000 rupees which we have today is going to be worth more as compared to the same amount 1 year down the line. Okay, so in other words, we can say the worth of 1000 rupees is going to be same as compared to the worth of 1100 rupees 1 year down the line. So today's money is worth more as compared to what it is going to be worth tomorrow, right? That is time value of money. And this very concept is very much used while deriving net present value. Okay, having understood this, let us see this simple problem. We have to calculate NPV, that is net present value, for an investment with a single cash flow. What does it mean? So let us read this. Assuming that we have invested rupees 2000 in a project and at the end of 1 year we are getting a cash flow of 2200. with applicable risk-free interest rate being A 10% or B 8%. Now these are the figures given to us. How much we are investing? 2000. After 1 year, we are getting 2200 rupees. We have to calculate net present value, assuming that risk-free interest rate is 10%, B 8%. So we will consider first 10% and then 8% and then we will try to derive net present value. And what is this risk-free interest rate? Here it is written, the risk-free interest rate represents the interest an investor would expect from an absolutely risk-free investment over a specified period of time. For example, government securities. Here, the likelihood of default is almost nil. Whatever we are promised, we are going to get. And that is precisely what is called risk-free interest rate. So what happens is we can take this 2000 rupees and deposit in a bank where we are getting a risk-free interest rate of 10%. So this 2000 rupees will become 2200 rupees after 1 year, right? Without doing anything, simply depositing this money in a bank where we are getting a risk-free interest rate of 10%, we are generating 2200 rupees. Then why should we take up any project? Why should we invest 2000 rupees in a project? Because investing in a project entails lot of risks, right? So let us avoid that. Simply keep in the bank and get 2200. So if the risk-free interest rate happens to be 10%, if we are getting 10% in the market, this project is not at all viable. And if we are considering this interest rate, no, we will not invest in project. We will simply keep it the back and generate 2200. Well, that is all about 10%. What about 8%? Look, if we deposit 2000 rupees, the 8% interest rate will make this amount to become 2160 rupees after 1 year. But look, if we invest in this project, this 2000 will become 2200. It is very clear that investing in this project is viable now if risk-free interest rate happens to be 8%. Why? If we deposit, we are getting only 8% after 1 year. That is 2160. This amount is becoming 2160, right? Our invested amount plus interest that we are getting after 1 year. But then in this project, if we take up this project, we are investing 2000 rupees and after 1 year, cash inflow is 2200. That is more than 2160. That means we will take up this project. To put this thing in simple words, this is what is all when we talk about net present value. This is all about net present value. But let us do the calculation, right, in a formal way. Now, what we can do is we can use, say, this formula and calculate how we are going to derive net present value. But before we use this formula, let us uh, calculate here. So how we'll go about it? Now let me remove all these things. This we already discussed. There's no need. No need of this. No need of this. No need of this. No need of this. Okay, let us do this. So what we are investing? 2000 rupees. Okay, and we will consider interest rate to be 10%. So how we can calculate net present value? We will say 2200 rupees after 1 year And how we can derive net present value? We will divide and we'll say 1.1. What we are going to get? Okay, let us round it off to 2 decimal here, 2000. So what is this? Net present value is 2000. So whatever we are going to gain, that is 2200. And the present value is only 2000 rupees, which means when we take up this project is making no sense if the risk-free interest is considered to be 10%. However, if we consider 8%, then what will happen? Just see, we'll write 08, and then what happens? 2037 rupees 4 paise. Look, how much we invested? 2000. At the rate of 8%, right? This would have become, this amount would have become 2160 only. Whereas, whereas this project is giving us 37 rupees 4 paise more. Look, with 10% net present value is 2000. It is more than 2000. That means 37 rupees 4 paise is extra over and above what we would have earned had we kept this money with the bank where interest rate is 8%. So if the interest rate, risk-free interest rate is 8%, this project is becoming viable. And if the interest rate is 10%, this project is not viable. That is the concept. Okay. Now, what you can do is we will use this formula. Whatever we have done here, we will do in a formal way. So what is this formula all about? It says that, look, cash flow T. T denotes period. And here the period starts from 0. What is 0 period? 0 period is the period when we are putting in money, when we are investing. That is cash outflow. In our case, it is 2000 rupees. And cash outflow we will always write in negative figure. It will be written in negative. Minus 2000 we will say. And period T will be what? 0. Okay. Divided by 1 plus I. What is this I? This I is risk-free interest rate. And again, raised to the power T. Again, what is that? Period. Period 0, period 1. In our case, we are only considering, look, we are considering only single cash flow. There is one outflow and there is one inflow. That's all. Okay. Now here, so what we are doing, let us see what is going on here in detail. First, what we are doing, we are writing minus 2000 divided by 1. See, this is 1 plus what is interest rate? We'll consider 10%. It has to be decimalized. It has to be written in decimal form. Okay. Okay, this. Now, this entire thing should be raised to the power of 0. So what happens? What we will get? We will get minus 2000 only. Why? Because if we do this stuff, only this, any number raised to the power 0 is going to give us 1, right? And then in numerator, what we have? 2000. So minus 2000 divided by 1 will be 2000 only, which means this is equivalent to writing just minus 2000. But we are writing like this only to make sure that there is a consistency so far as this formula is concerned. So we are writing. So we could have written directly to minus 2000, but we are writing According to this formula, we are writing uh, interest rate, and we are also talking about period, though it is having no impact so far as calculation is concerned. Great. What is the next part? So this was all about outflow. Mind you, we have to talk about outflow in negative. We have to write negative figure. So 2000, we should not write 2000. We should write minus 2000. And cash inflow, that will always be positive. So 2200 rupees is what? Our cash inflow. So what we'll do? 2200 divided by, what is that? 1 plus, what is interest rate? Again 10%, like this. And what is this period now? This period is 1. Period 0 is this year. Period 1 is 1 year down the line. So what we'll say? Raised to the power 1. And when we do this, what we will get? We'll get 2000 rupees. Correct? So let us again round it to 2 decimals. 2000 rupees. Correct? So this is 2000. The minus 2000 plus 2000, we are getting what will be the net present value? The net present value will be 0. So this I calculated separately, this part, and this part is here. Now what we will do? We will simply put the result into the variable called NPV, and we will print NPV, that is 0. What do we conclude here? We conclude that, look, this investment of 2000 rupees where interest rate is 10% makes this project unviable. There is no use of investing this money in the project where NPV is just 0. It should be more than 0. Then it will be viable. Great. So having seen that, can we now consider interest rate to be 8%? Okay, that has already been done. When we are calculating for 8%, see what is happening? 37.04 versus 0. Here net present value is 0. Here net present value is 37 rupees 4 paise, which means if the interest rate is 8%, we will take up this project. In other words, if we will take this 2000 rupees and deposit in a bank where we are getting 8% interest, 2000 is becoming 2160 rupees after 1 year. But if we invest this 2000 rupees in the project, and if we do the calculation for NPV, we are left with some positive value. So this 37 rupees is more, right? As compared to what we would have earned by simply putting this money in a bank. So we will take up this project. That is all about NPV. See, to simplify thing, we have taken this example where there is only one cash inflow and there is an investment of certain amount, right? And period 0, period 1, period 2 means we can consider 0 to be first year, 1 to be second year, 2 to be third year, so on, so forth. Okay, so far so good. But you know what? There could be a multiple cash inflow. Maybe there will be one investment, that is outflow of cash will be once, and there will be multiple cash inflow, means period 1, period 2, period 3, so on so forth, cash inflow will be there. We have to calculate all cash inflows and just derive net present value and just see whether the project is going to be viable or not. So what we will do is we will consider multiple cash inflows. Before we do that, look, we use this formula to arrive at NPV for 10% as well as 8%. There is another formula. What is that? See, here the period is 0, right? There is another formula. Here, period for this portion, the period is not from 0. It is starting from 1. That means here we will only consider cash inflow. We will not consider cash outflow here. We will consider cash outflow, that is initial investment, separately, and we will calculate this afresh. So what we will do? Look, this is our period 1. So we are calculating present value for 10%. We are getting some amount, and then we will say, okay, that present value minus initial investment. What is my initial investment? 2000. Then what we will get? 0. We know for 10% it will be 0. But what we are doing, we are using different problem. Slightly different one, right? Here the period starts from 1. Here the period starts from 0. Okay. And if it is 8%, well, 37 rupees 4 paise. Correct. Here what is again what we are doing? We are calculating. There is only one inflow, right? Single cash inflow. So that single we are considering, that is our present value minus 2000, that is initial investment. We are deriving net present value. Great. As we discussed about multiple cash inflows, now we will solve for this problem. Now what is this? Here there are 4 periods. 0, that is now. 1 means 1 year down the line. 2 means 2 years down the line. 3 means 3 years down the line. And cash outflow, that is initial investment, is minus 2000. First cash flow, that is after 1 year, cash inflow is 1000. After 2 years, cash inflow is 800 rupees. After 3 years, cash inflow is 1100 rupees. So there are multiple cash inflows, and we have to calculate net present value for this and just see whether the project is going to be viable or not. In other words, whether we will take up this project or not. So now what we will do? Simple thing. Whatever we did for only period 1, now we will do for multiple periods. First, we will use this formula. In this formula, we will start from period 0. Period 0 pertains to investment, cash outflow. Period 1 onwards would pertain to cash inflow. So look what we are doing here. See here, cash outflow minus 2000. Okay. Anyway, we are writing like this, but the end result will be minus 2000 only. We will not write something like this, correct? We will not write something like this straight away. No, we will write this entire stuff. Though, although it becomes minus 2000, still we have to maintain the consistency according to this notation, and hence we will write this entire stuff. Okay. Then period 1. What is period 1 cash inflow? 1000 divided by 1 plus 0.08 to the power 1. That is for period 1. Here cash inflow number 2, that is after 2 years. Again same calculation here, period 2 to the power 2, and then 1100 to the power 3. Everywhere same interest rate. So what we will do now? Once we do the calculation, the present net present value is coming 485 rupees, which means this project is very much viable and we will take up this project. This is making money. Okay, that is fine. Can we see what would be the percentage of interest that will make this unviable? Let us see that. Let us try this. We will consider maybe, okay, we can say 10, right? 10%, 10%, 10%, 10%. Well, even this is viable in this case when there are multiple cash inflows. Let us increase this percentage to 25, 25, 25, 25. Minus 124. What does this mean? This means that if we are getting risk-free interest at the rate of 25%, if we invest this money or deposit this money in a bank, the interest will be so much that there is no need to invest in this project. Look, investing in this project is giving you minus 124. So we can make more money by investing this in a bank rather than investing in this sort of project where cash inflows are like this. Correct? So this is the calculation we have done using this formula. What about this? There is only a little difference, right? So what we will do, formula B, that is was formula A and this is formula B. What is this formula A? This is formula A and this is formula B. So let us talk about B now. So 8%, we should get the same figure, right? It's not going to be anything different. 485. And if we do for 25%, for 25%, what will happen? Okay, make it 25, 25, 25, 25. See, minus 22. Good. So we have learned how to calculate net present value for various interest rate and just conclude as to investing in a particular project is going to be viable or not. But look, we cannot write something like this. This will lead to errors, typos. What if we have many cash inflows? We may have 100 cash inflows. Will we keep writing like this to the power 1, to the power 2, to the power 3, 4, 5, 6? It will be susceptible to committing errors. So we should not write like this. So what we will do now is we will use list comprehension of Python and do the calculation. So what we are doing here, same stuff, right? Period 0, 1, 2, 3, cash flow, same minus 2000, 1800, 1800. And rate is what? 0.08. This list comprehension has been written and we are deriving this same figure here. So let me first explain how it is working. See, first, let me break this. This entire line I'm breaking into pieces. See, we are writing list zip period minus inflow. See, let us execute this. And here when we do, what happens? 1 period 1 is 1000, 2 is 800, 3 is 1100. But this is formula B, right? What about formula A? This is formula A. Okay. So let us discuss this first. So this part here we are writing, right? Here we are starting from 0, period 0. That is cash outflow is 0, 1, 2, 3. These are cash inflows 1800, 1100. Okay. So okay, what is going on? I have to do this and then this. So 0 period minus 2000. This is cash outflow. Period 1, cash inflow 1000. Period 2, cash inflow 800. Period 3, cash inflow 1100. So this is the piece. Then what we are doing? We are saying something like this. We can say first, say PCF, okay? This PCF, and then this entire piece we will write here, correct? And we will run that. What happens here? Okay, P, we should write like this within parenthesis. Look, we are getting this. So till this point, this is how it is behaving. Now what we will do is we will say that, look, what you have to do is this CF, cash flow divided. In the very first instance, what will happen? Minus 2000 is coming here. And what is that? Our formula? Our formula is 1 plus, what is rate? Rate is 0.08 already written. Now close the parenthesis. This let me remove. And then what will say? To the power what? P. What is P? The very first cycle will give us, iteration will give us 0. Correct? Next. So what will happen? First it will be like this. Minus 2000 divided by 1 plus 0.8. Okay, put this within parenthesis and raised to the power of 0. Correct? 0. Next. Next will be what? What will become next? Next will be this second iteration will say 1000, 1 plus 0.8. This is raised to the power 1. Okay, comma. And then what it will be? Then 800, right? So let me copy paste to save time. Here we will say, now this is this, it is 800, period is 2. And then again here cash inflow is 1100, period is 3. Okay, this is what would be the output when I run this. Now just see here, what will be the output? Look, this is this. The result of this will be what? This. The result of this will be this will be this. The result of this will be this. The result of this will be this. So let us do calculation. So we know that this will be minus 2000 only. Correct. Okay. Okay. Next. This. See, 925. And then this. We could have run there itself, but anyway. Oh, what happened? Two commas. No. 685. Correct. And then this piece. Hmm. Again two commas. Hmm. Okay, 873. So this entire line is giving us this output, and we are taking this output, and eventually what we are doing, we are saying sum, correct? They will say sum. Okay, there is an error here. Why we are getting error? Okay, one sec. Okay, so the mistake is this. We have to make it a list. Then sum will work. Okay, list now 485. So that is precisely what we are getting here. Okay, so this was the explanation about this list comprehension in detail. So let me remove this now. Here, what we have done is we have used which formula? Formula A we have used, right? We will use formula B. How to go about formula B now? Look, here the same thing, but we are not talking about zero period and cash outflow also. We are writing separately. And the list comprehension will be only for three elements, three periods and three cash inflows. See, we are calculating this only for three cash inflows, and whatever results are coming, we are saying plus outflow. See, outflow is in negative anyway. So this minus outflow will again give us 485. This is slightly different as compared to this. Here we are not clubbing cash outflow with cash inflow, separately calculating this. Why? Because this is what is the notation. This formula talks about considering initial investment or cash outflow separately, and that is what we have done here. Look, this is what we have done here, correct? Let me remove this. Now what we will do is, having understood how to calculate net present value, in the next video we will use pandas to make the format neat and clean and do this calculation all over again, considering more problems. Thanks for watching, and I will see you in the next video.